So this question is a question on harmonic conjugate, problem D. Yeah. Um, you know, whenever we are giving u only in a function, we are expected to get the second part of that function, f. That's the main function f. And that second part is v. And is v is the harmonic conjugate of u. Yeah. So we need to use u to find v. Now we normally use or follow the Cauchy-Riemann principle to find out what our v should be. So your v is just the complement of u, so that the function f becomes what? Analytic, or satisfies Cauchy-Riemann condition. So how do we now find that? We have to find our u sub x and our u sub y from this equation, that the main equation that is given. And when you do u sub x, you see that you'll be having 3x squared. That's differentiating it with respect to x and once. The 3 will come to the front. You see, ba? Remove 1 from that 3, you have 2. 3x squared minus this s now is just s to the power 1. So if you remove 1 from that 1 here, you have 0. S to the power 0 is 1. And so it doesn't make sense. So you may not need to write it out. So you see that y squared is remaining because y squared is a constant. Now you do your u sub y. U sub y, this is a constant, it will go. You know, this is linearity, law of linearity. You will do it one after the other. So this one will give us 0. Then you now go to the next term in the linear equation. So if you do this one now with respect to y, 2 will come to this side. 2 times 3 is 6. So this s, why is it y? Because I remove 1 from that 2. That's why it is what? Y. So when you have gotten minus 6sy, and then you have gotten this, the next thing is now to put them in Cauchy-Riemann condition form. Remember that Cauchy-Riemann says us equals to vy. And now we know our ux as 3x squared minus 3y squared. You see, ba? Why the thing is this way, vy equals to us, is that we want to find this thing in terms of v. Instead of using a u, we'll be putting it in terms of v now. That's why it's vy equals to us instead of us equals to vy. Of course, you know, all these are the same thing. Carry goat, tie rope, tie goat. They are the same thing. You can carry goat and tie rope. You can carry rope and do what? Tie goats. So they're all the same thing. So now moving further, also in this case, instead of saying uy equals to minus vs, we are saying vs equals to minus what? Uy. And our uy is minus 6sy. When that minus combined with this minus, we'll have 6sy. So moving forward, I haven't gotten these two equations now. The next thing is that we're going to take our vx. What we want to do now is I want to get another vy. We already have vy here. See vy here. We already have vy here. We want to get another vy from this vx and then equate them together and find something. Now we will be using this vx. Now we would integrate it. You know, when you have a derivative, to go back to what it was, you have to do what? You want to go back to what this thing was. You want to go back to v. You have to integrate it. You now get the main v. So this vx now would bring it here and integrate it to get the main v. You get. And when you integrate 6sy, it means adding 1 to the power x. That's when integrating with respect to x. Adding 1 to power x, that's 1 plus 1 is 2. And using that same 2, you have another place to divide it. So when you add 1 to this place, you have 2. That's the 2 you are seeing here. Using that same 2 to divide it, that's used to divide 6, you have 3x squared y. Normally, you'd always add a constant when you are doing all these things, plus g of y. The constant is not like adding c. This one you are adding g of what? Y. Because you differentiate related to x, you'll be adding g of y in this case. Sometimes in your listing you will see something like c of y when you are in the class. So it's always c of y in your class. So where g of y is an arbitrary function of y, now compute this. Now that we have this, we want to from this v now, this is just normal v, and get v sub y, another v sub y. Remember, we already have v sub y. You want to get another v sub y from it. So if we already have the main equation v, how do we get v sub y? By saying differentiate v with respect to y. When you do that, you have v with respect to y. You have this y will go. It's just 1 now. So if you put this is 1, do normal thing, y will go. You have 3x squared plus g of y is a function. So you don't know what is inside the function. So you just call it the g prime of what? Of y. You have differentiated it already. So you now have this equation and this other equation. So this is vy and this is also another what? Vy. We can equate this and this together. And when you look at it by comparing it, you see that this already, g prime of y is equals to minus 3y squared. But we have to just show working. Let's go down. So set equal to require this, just speaking grammar. So we're equating this one with the one at the top I showed you before. So when you equate this with that one at the top, that's this one now, together, you see that your g prime of y is equals to minus 3y squared. You see now. So when you want to get g of y, like the main g of y, you will now integrate sort of different, you integrate, because this is a differentiation already. You integrate g prime of y by adding 1 here, that's 3, dividing it by that 3, you have minus y cubed. Then you add your constant c. You see, but you take this thing now, there's a place you had g of y before. You go there and replace it. So come and put g of y, what you're going to g of y, put it inside there. When you put it there, that's already your v we have been looking for. So that's it now. This is the v we have been looking for. You replace g of y in that very equation. You have this 3x squared y minus y cubed plus mc. So that's all. So the next thing you may be required to get the function f of z. Of course, f of z, as you know, is equal to u plus iv. Put your u, put your v. Your u was already given. Then you have gotten your v as this. You may not need to put a constant, and just put it this way. You can put a constant inside the plus c. It's still okay.